All right, so here's the second part for the review. I already went ahead and did start up some of it, and then I realized it wasn't recording, so I'm going to backtrack a little bit. This problem is about a kangaroo jumping, and it tells me that x is the horizontal feet that he jumps, and h of x is the height in feet. And so what I did is when I looked at the first problem, it was in vertex form, and I saw it was an upside down parabola based on this a being a negative value. And then because it is in vertex form, what I did is I went ahead and found the vertex. What makes that 0 is 14, and then the 6 as is. So my vertex is 14, 6, which means he went over 14 feet at the halfway point, and he's up at his highest point of 6. But then if he keeps going to where he lands, that's another 14 feet because the vertex is in the middle. So if this is 14, this is 14. So how high can a kangaroo jump? Well, that's the 6 feet high. How far can it jump? Well, 14 feet, and then another 14 feet would give me the 28 feet. Now, the idea is as the kangaroo is jumping, so he's jumping, at one point he lands on a trampoline. So let's say this is where the trampoline is now. And he jumps an extra 5 feet up into the air. So when he jumps an extra 5 feet into the air, that's going to make my height of my vertex go up another 5 feet. So that means my vertex is still over 14, but now it's up 11. So the way I would write that is I would still keep the same a. And now I'm going to still have the x minus 14. But instead of going up 6 feet tall, now it's going to go up 11. Okay? All right, next problem. What I need to do is write this quadratic function into factored form. So that's all I'm going to do is just factor it. The first thing in factoring, according to that green or maybe pink page that you have, is you want to take out a greatest common factor. So I'm going to take a 2 out. And now I'm going to find the factors of, remember there's an a here, a times c, negative 12. That get me to 1. And those factors are going to be 4 and 3, and I'm going to want to make the 3 negative. And now I can go, because this is technically easy factoring since there's just an x there, that's going to be the 2 that was originally factored, and then x plus 4, and x minus 3. And now this is in factored form. And I would actually have this equaling f of x, not 0. All right, next thing I want to write this into this vertex form, into standard form. So that means I need to get this so there are no parentheses. And that x plus 1 just means there's 2 of them. I'm sorry, that x plus 1 squared means that there's 2 of them. So the first thing I'm going to do is just break this down. I'm going to multiply this, or FOIL, as you might like to call it. The x is going to go into both of those, so that's x squared plus 1x. And now I'm going to let the 1 go. And there's another 1x and a 1. And when I'm done putting that all together, I have x squared plus 2x plus 1. So that's x plus 1 squared now broken down. But I still have this negative 2 in front, and I still have the 4 left. So the next thing I'm going to do is take this negative 2 and just factor it through. Or not factor it, distribute it through. So I'm going to get negative 2x squared. Then I'm going to get a negative 4x. And then I'm going to get a negative 2. And then I still have the 4 at the end. And now to get it into standard form, I need ax squared, which is still there, bx, and then c, which I'll just combine those two. And there it is in standard form. All right, suppose the equation ax squared plus bx plus c equals 0 has no real solutions. That means it's never going to hit the x-axis. And it has a vertex that lies in the second quadrant. So I need to draw a possible version of this. And so here's my, I could say it's here, or I could put it anywhere, but the idea is when I draw my parabola, I need to make it a regular parabola. Whoops, that wasn't very good. That goes like this instead of upside down, because if it goes upside down, eventually these end behaviors are going to hit the x-axis. So I have to draw a regular parabola where a is a positive number. And so that means a is a positive number, and the reason why is because if a were negative, then the parabola would be upside down. and then go through the x-axis, which means it would have real solutions. So I don't want it to have real solutions. I want it to have imaginary solutions, and this is a type of graph that would have imaginary solutions. All right, now we're going to take this graph and suppose it translated, so it shifted left, right, up, down, whatever you want it to do. So that's now in the fourth quadrant. So this shape's just moving down here. So, I can move it maybe a little left or a little right, but the idea is it's going to go down into the fourth quadrant. So now draw a possible version. There you go. And does it have any x-intercepts or 0? Yes. It has 2 right here. Whatever those values might be. It doesn't ask me that. X-intercepts or 0s. All right, let's go to the other side. So on the other side, so a quadrilateral is divided into 2 right triangles and is shown in the figure. And what I need to do is find the length or the value of x, and then find the length of each side. So the idea is I have 2 right triangles. So I have Pythagorean theorem for this triangle and Pythagorean theorem for this triangle. And their c squared is actually going to be the same between the two. So that's what this means. If I just take one triangle, so a squared plus b squared, that'll equal c squared. Well, this c squared is the same for this one. So the other triangle will also be then a squared plus b squared. And they're going to be equaling each other because they equal the same value. So I'm going to square 6x. That means 6x times 6x. That's 36x squared. 8x squared is 64x squared. Here's my equals. This is 25x squared. And when I take 300 in the square, I get 90,000. So just clean it up. I will have to solve, but I do have the same type of x. They just have different coefficients in front of them. So the left side becomes 100x squared. And now I'm going to start getting the x by itself, move the 25x squared over. I'm going to subtract it. And now to get x by itself, I'm going to divide by the 75. So I do that on my calculator, and I will get that x squared is 12,000, or 1,200, sorry. And now I'm going to take the square root. So, you could do this a couple different ways. One is I could take the decimal, and here I'm not going to take the negative version because a negative amount would imply that I have a negative side length, and you don't have negative side length. So I'm going to keep the positive version. The other thing I could do is find factors. So I use my factor program, and I break this down into these 2 factors. And then 400 has a perfect square root of 20. So you could use either of these. It doesn't matter. I'm going to use this one. So I found x. Now, what I need to do now is take that x and sub it in here. So that just means I'm going to take 6 times this. And that gives me 120 square root of 3. I'm going to take 5 times that amount. That gives me 100 square root of 3. So that's that side. For this one, I'm going to take 8 times that amount. That's 160 square root of 3. So I found x, and then I found my 3 side lengths because we already knew this side length. All right, the number A of tablets sold in millions can be modeled by this function, and T represents the years after 2010. So in what year did the tablet computer sales reach 65 million? So that means my A is 65 million. Well, this is all in millions, so I'm just going to put 65 in there. And now my job is to solve for t, and so I have to ask myself how many types of t's do they have? And there's 2. So that means I either factor or do the quadratic formula. Either way, I got to bring the 65 over by subtracting it. Sorry about that. Just wrote it wrong. That should be a t here, and then when I subtract that over, I get minus 48. So that's a 0.5 t. I want you guys to get confused here, so let me fix this real quick. Okay. It didn't turn out much better, but that's okay. All right, there's no way I'm going to factor this. We have never factored with decimals. So I'm going to go into the quadratic formula. Here's my A of 4.5. Here's my B of 43.5. And here's my C at negative 48. So I'm just going to put this in the quadratic formula. So opposite of B, plus or minus. Now I'm going to take B and square it. So 43.5 squared is this number. And minus 4 times A times my C. And then it'll all be divided by 2 times A. So 2 times 4.5 is 9. So what I do is I went into my calculator and I typed everything inside the quadratic part, that's the discriminant, in there. And when I'm done, I got this. So moving up here. So here's the opposite of B still, plus or minus, and now I will be taking the square root of this number. And then I go to my calculator and I type in negative 43.5 plus the square root. I hit enter. And then I divide by 9. And as it turns out, I get one really nice answer. That's 1. And then I'm going to take negative 4.35 minus the square root, hit enter, divide by 9, and I get this number. And I only want the years after 2010, so this is positive, so that's after. This is negative, so this is before. So that's the only thing I need is the 1. So the year would be 1 year later, which would be the year 2011. Whoops, too many ones. Okay, next problem. A signal from a cell tower is bounded by inside a circular region, that's this, and it's made of a straight highway. So first, there is a correction to this one. I had to change some numbers around, so this worked a little nicer. I changed this into 3,690, and I changed this equation into just x plus 30. So you don't realize this, but this is a circle. That's why they said a circular area. And then this is a line. And as I just want to know, is this line going through it? Is it touching it? Is it not meeting it all? That's what we're trying to find out, is how does that straight highway work with the circle? Does it go through it, touch it once, or is it completely separate? So I want to see if there's any points they have in common. So I'm going to use my substitution method and take this y, that it equals x plus 30. Sorry, I know this is shaking a lot. And I'm going to put it into the other equation. All right, here is the cell phone tower. So the idea is when a cellular tower emits a signal, it does it in a circular fashion. And there's this highway, and I want to know, is this highway going through the circle, so I'll get service all the way through that stretch? Is it maybe just touching at one point, so I'll have just very little service, or is it not touching at all, so I'll have no service? So I just want to see if these two intersect at all. So what I'm going to do is I did a few changes. First, this number needs to change into 4,500, and then this equation is just going to be x plus 30. And since I'm going to try to solve these two together, I need to use either the substitution method or the elimination method. So I'm going to be using the substitution method because the elimination method needs a lot of things lining up. I need y is lining up, x is lining up, x squared is lining up, and this has an x squared, but this doesn't. This has a y squared, but this doesn't. So the substitution method is what I'll use. So I'm going to take the fact that y equals all of this and put it right in there. So in for y goes this, 4,500. And now I'm going to do what this x plus 30 squared means, which is multiply them twice to each other. And I'm going to FOIL. I get x squared and 30x. But when I multiply this 30x in, I get another 30x, which will actually make that 60x, and then 30 and 30 is 900. I still have the x squared that I started with, and the fact that it equals 4,500 at the bottom. And now, because I have more than one type of x, I'm going to have to factor, so that means I need to get into standard form. So, for instance, combine these, and then bring the 4,500 over. And when I bring that 4,500 over from 900, I get negative 3,600. And now before I factor, I notice I can take a 2 out, so I'm going to do that. And then from there, what I would want to do is find factors of negative 1800, because this is simple factoring, and with your graphing calculator or your factor program, you can do this. That get me to 30, and those factors are going to be negative 60 and 30, and then my parentheses now are 2 that I had before, x minus 60, x plus 30, so what makes those 0 would be 60 and negative 30. So those are my two x values, which means now I need to find the two y values. So I'm going to take those two and put them into here. So if x is, what was it, negative 30, and I put negative 30 into here, my y is 0. And if x equals 60, and I put it into here, my y is 90, right? Alright, so those are my 2 points. Now the last thing they want me to do is to actually find the distance now between these 2 points. Sorry, my arm's getting tired. That means I need to do the distance formula. So just throwing a little bit of geometry in there for you. Alright, let me get a little more stable here. Okay, so the distance formula. So here's one point. Here's the other point. And in the distance formula, which is a square root, I put my x's, so I'm going to do 60 minus negative 30 squared, and then I'm going to take my y's, 90 minus 0, and square it. This will all be in a square root as I do this. So here I get 90, and I'll take 90 squared. Here I get 90, and I'll take 90 squared. And 90 squared, and again, this is still all staying in a square root, and when I take that and I put them together, I get this. And then I'm just going to take the square root of that amount, and that length, or that distance, not x, the distance is, if this is in miles, 127.28 miles. And that's it. That's your extra review.